Hello, everybody. So week 7 here, and well, y'all are aware the semester this fall is doing a Wednesday start, so it ends on a Tuesday. So next Monday will be our last day in class. And yeah, game engines are huge. Game development, there's quite a bit involved, so kind of barely scratching the surface here. I did glance at the list of people registered for the 248 class in the spring, so it looks like a lot of y'all are taking that and a few others. So it should be what we're starting to look at today. What we're doing today is pretty much going to be that whole course. So today is kind of a quick introduction for it, and that entire 8 weeks we will spend making games in Unity. I'm still a little torn on the book for that course. There's one that I really liked, which is a Cengage book called Game Development with Blender and Unity, but it is probably 90% Blender and just kind of barely touches on Unity once we get the artwork finished. And the other book that I really like is Game Design, Prototyping, and Development in Unity. And it is purely a C#. It is pretty much just all C#. And like where it's talking about art assets, it says import your art assets and doesn't say anything about where to get them or anything. I'd really like to use the 2 books together, but I don't want to ask people to buy 2 textbooks because textbooks are expensive and usually budgets are tight on the way through school. But I think there might be a way to do like choose some of the important chapters out of the Blender book and maybe use most of the C# book, but still got a couple weeks to put that together. That's in the future. But that 248 class is pretty much going to be an extension of what we do today. Maybe some from the last week. Both textbooks that I like have examples of card games, which is a very good, straightforward way to practice game development skills, get the animations and the movements and all the data processing in the background. But that's in the future. Coming on the end of this course, so I'm going to try to keep the lectures today, Wednesday, and then next Monday a little on the shorter side. That way there should be plenty of time to work on any remaining assignments or anything, get all those finished, the final projects. I know the end of the semester always gets a little hectic, so I try to make sure I always front load courses so that the load gets a little bit lighter at the end and there's plenty of time to get everything, all the work done. I've got most of the grading done. The Unity 2D tutorials, it'll be a minute before I grade those. I think we already talked about it. I believe I mentioned that pretty much going to get all the points for turning something in, but please don't confuse that with like me not grading it. I'm still going to read every line of code you wrote, and I'll go through it very thoroughly and probably have some comments and stuff. But on the technicality of the points, this class is about familiarity with the tools. And yeah, if you turn something in, then you are familiar with the tools to make that something you turned in. But I'm still going to go through it in detail and probably have some suggestions and things in the comments. Let's see, what else do I have on the to-do list? The computer club is going to have a game jam after the semester ends, the 17th, which is the Friday. The semester actually ends on Tuesday, and then on the Friday from like 1 to 9 o'clock is going to be some sort of game jam event. Did you all get a flyer for that yet? I thought she was going to send it out over the weekend, but I did not see the flyer. Okay, I'm guessing no flyer then. Nobody has any comments on that. Well, it should be coming out soon. I don't have the actual flyer advertising it. Okay, there's something in the chat room. Don't remember one. So it should be coming out soon. I don't have the actual flyer. I'll see if I can get a copy of it and send it to y'all because I'm pretty sure it's been discussed in here. Everybody in this class is kind of a gamer too. So something you all might enjoy, just an afternoon of playing games. I have the registration form because I put that together, but it was supposed to go out with the flyer, and I thought that was going to happen over the weekend. So I'll check and see what the delay is. But on the 17th, there is going to be sort of a game jam thing from 1 to 9 o'clock with prizes. I think a $25 Steam card and a $50 Steam gift card for prizes on that, which is always nice because games get a little expensive. So when you win, obviously a Steam gift card is going to essentially turn into a free game. So when you can win a free game, it's kind of nice on the budget. But I'll check on the flyer about that. Otherwise, we kind of ran out of time last week because I wanted to make sure there was plenty of time to do stuff. But we're ready to look at 3D examples in Unity and kind of quickly look at the artwork associated with it. It's a very art heavy subject. We can't necessarily avoid art, right? In more business-based software development situations, you can probably specify explicitly that you want to be a back-end programmer or front-end programmer and deal with the graphics, and there's a big separation. But they're so intertwined for gaming that we can't really avoid it. Right? When we go apply for game development jobs, probably need to have two portfolios, the art portfolio and the programming portfolio, to show off your skills. Does anybody have any questions before we get started into our example here? Okay, and I sent out some files just a moment ago. Oh yeah, there was something I wanted to look at on Ivy Learn. So I might as well point at those files. So in an Ivy Learn announcement about 15, 20 minutes ago, I sent out the files that I plan on using this week. There will probably be more coming. We'll talk about that as our example starts to come together in Unity. And yeah, you can see down here that I already have the spring courses. So where is it? The 248 starting to come together. So registration is open for the spring. Make sure you do that sooner rather than later. In one of my courses, the SDEV 265, that's the project course that comes at the end. Really, it's the paperwork course, because at that point, everybody knows how to program. We just go over all the official formatting and standards for paperwork and things like that. Make sure those are all up to par, and documentation, all the UML stuff, and make a big project. But there's only one person in that course, so that's probably going to be canceled pretty soon, and it's required for the software development degree. So they've started trying to cancel classes sooner rather than later. That way there's plenty of time for people to adjust the schedule. If they're the ones in that course that only had 1 or 2 or 3 people that got canceled and they need to pick that course up somewhere else, they want to make sure there's plenty of time to do that. So things are getting canceled sooner rather than later anymore. And our dean is retiring. I don't know if you all were aware of that, but Skip, he was stopped in the first day of class here. He is retiring in December, which means there'll be a new dean. So a lot of the things like course cancellations are going to be done before he leaves, and that way the new dean isn't overwhelmed coming in with short notice trying to get all that stuff ready. So especially this semester, courses with low enrollment are going to be canceled sooner rather than later. Yes, so about 15, 20 minutes ago, I sent out some example files. If you want to download that. Whoops, that's not the link I wanted to click on. I'm going to click on syllabus. I was just going to point at something. It's not just for this class, but for all of your classes on the syllabus, there's a section called Course Outline of Record, all the official stuff. And in that is major course learning objectives, the things you're kind of expected to learn in a course. Right? Most of our courses are prerequisites for other courses. So when you get in that other course, they're going to expect that you learned the stuff on this list. This is the first draft of this. So when he put it together, he had a book in mind already picked out, and then we weren't able to use that book because the publisher lost the rights to that book for some reason. So it'll probably change in time, but these things are usually kind of cryptic too. Sometimes it takes a little bit of thought to make sure, but near the end of the semester in all your courses, you want to go through, and this list, basic simulation and game design. We kind of looked at the tools we have to use and some of the features for that. The book was a lot about the design, the thinking, conceptual sort of stuff, getting in the right frame of mind for it. History and evolution, that was explicitly a chapter in the book he had in mind. So he included it on the list, and then it wasn't included in our book. That's what the history essay is for. But it's an interesting history. So there's a lot of neat points in the history of game development that are well documented because it's all a fairly recent history. It only goes back to the earliest would be the 1950s when they did the first tic-tac-toe games. So it's a well documented, fairly recent, fairly young history. So there's not a lot to it as opposed to like world history, studying the evolution of languages or something. There's eons of that. So we go different categories, genres of computer games, kind of did that in the discussion board some. Non-entertainment goals, that was explicitly a discussion board last week, but sometime recently. I threw it in there to make sure it was covered somewhere, but there's more than that. I did see some people mention simulators, some of the training simulators and flight simulators, and those are basically identical to how game stuff works. The flight simulators are a little bit fancier. They basically, I have an uncle that works on those, and he works for Lockheed, and they basically took one of their cockpits that would have gone through the assembly line and put on a plane like normal, replaced the windows with monitors, and then basically all those controls become fancy joysticks and controls for video game sort of simulation. Goes together just like our video games. And with modern graphics, those screens that replace the windows look realistic. So it really seems like they're flying and stuff in the new ones. But for the word simulation, because that's what we're doing with the game design, we're simulating real world situations, physics, in order to tell a story usually. Storytelling is important. We saw different things, different game platforms. That's kind of included in the history part. Interface design, physics and realism, and just a few points, but I wanted to remind you about that list, not just for this class, but for all of your classes. There will always be that list. So when you get near the end of the semester, always make it a point to look back at that list of major course learning objectives. And if there's something on that list, they are kind of cryptic sometimes, and it's hard to tell what they're even saying in some courses. But if there's something on that list that you feel like you didn't learn, those are questions you definitely want to ask as we get near the end of the semesters, because in your next course, that might be expected that you know that. Yeah, over the weekend, I added a couple things that wouldn't have been in the example last weekend. I come up with a couple ideas that will probably be good. And it's going to come in a couple stages here. So I'm going to create a new 3D game, just the general one, and call it in-class 3D. That seems like a good name. And go ahead and create that. So to start with today, it's just some basic, I'll say a basic expansion on what we saw in 2D. Using essentially the same things, same concepts we saw in 2D, and we'll just add in that z-axis value to get that third dimension. And then one of the things I realized over the weekend that hadn't been covered yet was jumping between scenes, which is essentially different levels. Some game engines call them rooms. Unity went with scenes. And really, when we're playing them, we refer to them as levels. So put together at least 2 of those. And I sent out a couple of little Blender files of models we can use for the worlds. I did not spend much time on them. The one of them I did in like 45. I don't think it was even over 45 seconds. I very quickly grabbed a cube and just split it up into a whole bunch of faces and stretched some of them upward to make like hills sort of around a valley. And then I went over to the sculpting tools and added a bunch of clay in randomly and grabbed the smoothing tool and went over that really quick. And it was probably 45 seconds. And yeah, obviously not a finished product in 45 seconds, but I was kind of impressed at how well it came out in 45 seconds. We'll look at a couple levels, and cutscenes would follow suit with what we've seen here. Hopefully you realize that was part of the reason for that option on the history essay to do animation, a narrated animation instead of typing the essay, because animations and sound are trivial in a game engine. Right? Everything we do is going to have animations and sound, so they're very, very easy to do. So when you go to do your cutscenes, it's essentially what you're setting up for controllers, only it's automated and running off timers and not changing. So it's just kind of straightforward. I always just set it up with like an integer counting how many frames have passed and use that as the timer. So like at frame 300, the character starts walking to the left, and at frame 600 talks to another character, and at frame 900, the conversation ends, and then the character walks off to the side and walks off screen left, and that's the end of the cutscene. Very easy to throw animations together quickly that way. Actually, I find it's a lot easier than using traditional video editing software. So usually when I do animations, I go to a game engine, throw the animation together with those tools, and then just do a screen capture to get it into the traditional video editing software. I think it's a lot easier than the traditional video editing animation software myself, but that might just be because I've had more experience with game engines. Okay, so just some basic movement and some cutscenes, so things we've seen before. So should look very familiar. Right, we still have our hierarchy. I'm in the default layout, which there's lots of different preset options for the layouts. I'm just going to go with the default one, or we can add windows and bring other things in. We saw some of that, but in general, it should kind of look familiar here. Uh-oh, my thumbnails like got stuck in a weird place. There we go. That's kind of out of the way, maybe. Nope, not really. Maybe it'd be less out of the way there. Or I could minimize the thumbnails. I guess I don't really need to see them. Get them completely out of the way. So it should look somewhat familiar. Have our scene area, our game tab. I have the animator open. The default one doesn't usually have that in there. We'll get to that in a moment. It's like we've seen before, just like with 2D, a little distraction can go a long way for humans. So it's best to do as much debugging as we can with the still images, and then bring in our animations, do some refinements, and kind of have a minimal amount of debugging to do once there's lots of distractions on the screen. I have our inspector panel where we can look at things, the project, which is sort of like a file explorer. The question had shown up doing something. Where's something that would, oh, well, the second button here, if you're on a PC, you'll have a similar button right below create. If you right click and pull up the context menu, here on my Mac, it says reveal in Finder. It's sort of like our normal file explorer, but it doesn't have full capabilities. there are some things that we can't do with this one. So it will just automatically open our regular file explorer or finder or whatever your system default for working with files and folders and directories is. So it doesn't have full capability, but it has a lot of the basics that we'll need. In our console for the output, we saw all that. Inspector panel. You'll notice we start with something a little bit more though. In 2D, we always had the main camera, but with 3D, we also have to have some sort of light. We need a light source. In 2D, it's implied that the light is just going straight on, but that's not the case in 3 dimensions. So we do have a light source as well. That will be important when we look at Blender stuff, maybe today, but probably Wednesday. I figure you all were probably more interested in the gaming part, so we'll look at that as a second afterthought. And I already made some images to work with. That's what those things I sent out were. Which I have that folder here somewhere. Here it is. So there's several images. And notice most of them I just left in the Blender file. So swamp and desert, that's our 2 little worlds. This desert scene I made in like 45 seconds. The swamp one, I don't think I spent over 2 minutes on it. It was pretty quick too. But so obviously not final versions, working versions. And that's what we want to have some versions to work with, because the really fine artwork, Blender can do the Hollywood quality realism, but that sort of thing takes some time. And that level of artwork tends to be the sort of largest bottleneck on time. That's what slows everything down, and what all the schedules have to be worked around is how long it takes to put that really good artwork together. So for our purposes here, we just need some more starting files. So I did a couple of these, and notice I sent the Blender files. So with the Blender files, we can bring them straight in here. Oh, whoops. I meant to create another folder to put that in. I'll just move it in another folder. And it'll take a second, but it should import here shortly. There we go. And the reason is, notice that it doesn't say anything about being a Blender file here. Unity actually works with a file format called FBX, which is one of the files I sent out is an FBX file. The animated character file is animated, so I'll drag that in. And notice they came in the same. So when we add a Blender file, it will automatically turn it to an FBX file. The thing is, so this one, if I expand it, see we got the material and the cube. That's just sort of an area. There's not much going on with it. When I expand this one, we have that armature that's involved, the combination of the armature and the mesh, the material being used, and then several animations already included. However, if I drag in the character, the Blender file for this, it might still show them. You'll notice it did the conversion and everything. We still have our armature or human or mesh, but we only have one animation. So Unity doesn't really like it when we work in the entire Blender file in there. They want us to go ahead and do that export. So that's something you might see in reference material, because people keep finding a way to work around it and bring our entire Blender file in. If you look at the alternatively, you can go to import asset and just look for it. But if you look at go to the Unity source code and look for a file that is for importing new assets, called that directly. Yeah, you can open that up. It's written in C#, and on line 43, there's this a variable, Boolean type variable that says Blender to FBX multiple action with underscores, spelled it all the way out. Blender to FBX multiple action equals false. So if you go in there and change that true, you can bring all those in. But Unity prefers us not to do that. So we'll see. So they keep adding more and more ways to block it. So you might see in reference material where you can drag that straight in and it will work, but they don't like when you do that. So we'll look at the actual FBX file. But if there's no animations, such as for the background, then that'll work fine. That's kind of the standard. Blender is kind of the standard they like to go with. So there's no animations on that, so bring those in. I'm going to organize them into folders, because just to express that point, this is a small, nearly trivial example, just kind of getting started on a few things. But organization is important, so I want to keep that in mind here. So I'm going to make a folder called models, which I guess is one of the things different than the 2D version, because remember in 2D we mostly work with sprites. And then just like we saw in 2D, we can just grab our stuff and drag it in here and have our game set up that way. So there's like a little desert scene. So on the mouse, if you right click, you can kind of spin things around. Middle click does your panning up and down, left and right click does your left and right spinning. If you have a little mouse pad, it's the Alt click does your spinning, and Control click Shift click, but one of them. Left click does your selection. You can zoom in and out by scrolling. And one of them does the panning, but I can't remember which one does the panning now. And none of the buttons seem to be working correctly for it. I thought it was Control click, but that doesn't seem to be working here on mine. No, with the regular mouse button, the middle wheel does the thing. Maybe it's Control Alt. Nope. There's a way to do it on the mouse pad. I'm used to doing it on a PC and can't remember. I should have double checked what the command was. It's a lot easier to have a regular mouse. If you're going to work in 3 dimensions, you probably want to just use a regular mouse because the controls are a little bit different. You can see that brought in our little desert world. Yeah, I spent 45 seconds on that. Obviously not a finished version, but I was kind of impressed at how well it came out with in 45 seconds. You can kind of see what I did here is I just made a cube. I randomly grabbed some areas here and here and stretched them upward. Made a smaller selection, stretched that upward, a smaller one. Then I came back with the chisel tools and kind of quickly went through that. That brings our scene in. Big desert object. Looks like the camera's below it from the view here. So I'm going to stretch that up. There we go. That way we're looking at something. Just to kind of get it on the right side of that, because once again, we're going to use that easier to use Cinemachine thing. Camera follows can be a little bit tricky, getting all the camera features set up. And likewise with same thing we did for our world, we can just bring our character in and kind of drop it somewhere. And over here we have controls to look straight on from a different axis. So like if we look from the top, we see, get a better idea of where he's at. Switch back to the side. Looks like he's way above the ground there. And just try to kind of get him to a good starting point. I'll break it down. And you can set him right on the ground. As you can kind of see there, when he gets to a certain, it starts overlapping, you can see it overlapping. What I like to do is just raise it a couple inches above the ground, especially if something gravity is going to apply on. That way I know it's clearly above there with the colliders and everything, so that whenever the game starts, that first instance of the game, it's going to fall down that last couple inches. I'll accentuate that a little here and leave it a foot or so above the ground. Kind of gets our character in there, ready to do something in this world. Oh, I almost forgot. Something you will probably see in a lot of reference material is suggestions to keep your graphics and logic separate. So you'll see things like in the hierarchy, to create an empty object and then drag that character animation down to be a child of that. So then we put all of our logic onto this game object, which is kind of an empty thing, and our graphics are a child of that. And that is pretty much all for your benefit when you see that. I'm gonna not do that here. It can be a good idea, and it's pretty much all for your benefit as a developer. Because then, especially for updating the graphics, you can work with your starting graphics and just change them out later. That could be a good idea. Actually, why don't I go ahead and do that? So this one, there's not really much to. There's not going to be a whole lot going on in the ground. It's just going to sit there. So I'm not going to worry about that. But I'll go ahead and create an empty game object. And I'll call this player. And instead of dragging the character in here, I'll drag it over here and just drop it onto that. Oh. It's not dropping on there. There we go. So that it's a child of that player object. Sort of the separation. And then later, where did that go? Oh, it's way over here. Notice the position ended up kind of weird. There we go. So setting that child at 0, 0, 0 isn't 0, 0, 0 in the world. It's 0, 0, 0 relative to this thing. And the advantage that offers is whenever you get the finished version of the graphics later, all you have to switch out is this part, because all your other stuff is combined in this. As far as runtime, it won't make a difference. As on Unity and most of our other major game engines that are going to compile the code, they have the optimization level in the compiler set very high. So it will look for things like redundancies. And when it goes to compile it, it'll say, oh, well, these two objects could be combined into one. So when it compiles it, the version that actually runs on the machine, that's already been combined to a single object. So this is only for your benefit, but it is a big benefit, because then when we get better images, we just swap out the image. And then this holds all of our actual game data, like a rigid body. So under physics, that we saw before, we can turn this into a rigid body so that the laws of physics apply. We'll want to freeze rotation, but like normal, I'm going to wait until an error shows up so we can see the issue and then know how to spot when that needs to happen. Which, yeah, I guess we could go ahead and run it now, if the camera can see it. I forgot to check and make sure the camera could see it. Off in the distance, we saw gravity took hold and he started falling downward. So it looks like gravity's going the right direction and everything. A couple things to note. Traditionally, let me get where I can see all three of those. Traditionally, mathematicians did our XY plane like a piece of paper, which you all have probably seen in math class, right? The XY stuff we draw on a piece of paper, flat, with Y going upward, X going to the right. A lot of times on computers, we flip the Y-axis so that on the flat surface, positive Y is downward, like lines on a page, or in game development, gravity going downward. That's just something done a lot. It's not consistent enough to call a convention, but you might see it more often than you see the Y-axis going up. And traditionally in mathematicians would alternate in 3 dimensions and put Z-axis going up and down, and then our X and Y are the horizontal ones. So it gets reoriented. When they built Unity, they decided to keep our X and Y like they would be in 2D and just go with the 2D expansion. So X, Y, Z, red, green, blue, that one is kind of standard that those go in order. X is almost always marked in red, Y is almost always in green, and Z is almost always in blue. So you can see just like the 2D, Y is up, our Y is the up-down axis, with X being a horizontal axis, and then they just expanded out that Z-axis. So it's Unity is even closer to just a simple expansion on 2 dimensions, because I remember we use the Z-axis in 2D to kind of layer things with what things are in front of others or behind others. We would just change the Z value. So they just kind of kept that trend going. So our X and Z values are horizontal and our Y value is the vertical one with Unity. That's not consistent across other game engines, because a lot of game engines went with the traditional mathematics version where the Z-axis is the vertical one and the X and Y are the horizontals. So whatever engine you're working in, you want to make sure you're familiar with that. So we saw a rigid body, and when it fell down, it just kind of hit the ground. So I'm going to add another component, collider, so that we know when it hits the ground. And we have a lot of different options, boxes, capsules. This thing right here, you will probably see in a lot of reference material. It combined a bunch of things. These things that we're putting together, the rigid body, the box collider, some joints, and several other things that we don't really have time to squeeze in, that are very, very common, that we do almost every single time. It adds those in. And when Unity added that in about 2.5 years ago, all of the YouTube channels that they sponsored, well, they included a request that, like, okay, well, if we're giving you money to be a sponsor for your video, we want you to cover this. So it showed up in a whole lot of material. I like to do it separate myself, and we can actually see the reason, my preference here. Anybody that's interested in programming is probably because you have a character trait that you like to be in control. That's a character trait that leads to the decision to be a programmer, right? We don't want to just work with the machine. We want to be the ones that tell the machine what to do. So I always like to state that explicitly, because you're heading into software development field. So remember that that is a trait amongst people that chose to be programmers. So when you're on a team of programmers in a meeting, remember that meeting is a room full of people that like to be in control. That is something that shows up in the industry, because that's a character trait we all share. So that character controller is a combination of things. So we have rigid body, we have all these controls, all of these variables and things we have access to, especially if I expand the info, have access to a whole bunch of stuff there. Box collider, we have a whole bunch of stuff. But you'll notice there's not nearly as many boxes down in the character controller. Not as many things we have access to as either of the other ones, let alone those two with 3 more things all combined into one. We'd expect a whole lot more boxes. So we lose some of our control when we do that. Obviously, the default values are going to be good ones. They're going to be nice values to work with, but that might not always be the case. So as you play around with the different things, get used to it, try that a few times and kind of get a feel for what it works good with and where you want some of that control, some of that more detailed control back. So for our class, I'm going to cover this. That is a combination of these things. So these things are included in that. So very similar. They're very, very similar. That was just a common combination that they went ahead and put together for us. But we lose some control. We don't have as much. It looks like that box collider's in an odd spot. So I'm going to bring that in. And over the years, I've found that it can be a lot easier to get that oriented looking from straight on. If we look from an angle, it might be a little hard to kind of tell exactly where everything's at. So that looks about right. Turn over this angle and just try to set these up. Set up this cube or sphere, whichever one, or capsule, or whichever collider you want to use. Try to get it about the right spot. That looks like it's pretty spot on every side from the character. Not too much below his feet. Remember, we're not doing the full simulation, right? Like this isn't a super powerful computer trying to simulate the evolution of life, right? The full simulation. We're doing the illusory simulation. We're trying to give the illusion of that effect. So like here in the desert scene, we might want our player to sink down a little into the ground to simulate that sand. So maybe bring the box collider up a little bit below the bottom of his feet, just to give that illusion that he sinks down into the sand when he's walking. Just little things like that you might want to keep in mind with your games. So we saw that with 2D, so no real change for the 3D. I guess the difference is they're named different. Instead of rigid body 2D, it's just the rigid body. And it's still called a box collider, but you can tell from the little diagram that it's the cube box, not the flat box. Then spheres and capsules, lots of different ones. And in order for it to stop when it hits the ground, we need a collider on the ground as well. And that ground's kind of a mess. If I zoom way out, you'll notice very quickly that a box isn't going to work for us, right? A box would surround everything, and we'd kind of miss the little valley there altogether. A sphere or a capsule, which is like a cylinder, those would be even worse, I suppose. Another option we could do, and you can do this on your character as well. I'll click on the ground, and all we need here is a collider to stop our character. You'll notice there's also a mesh collider. And remember, that's what we create with our 3D models. We have this cube mesh, a mesh of vertices and faces and edges that define that shape. So we can also set a collider up right on that mesh so that it matches every face of that instead of a particular thing, instead of just kind of roughly trying to estimate it. You can use that on your player, but like sometimes you want collisions to happen a little ways away from your player. Like here in a little while, when we get to the go to a second scene, we'll probably want we'll make a little gateway thing where Actually, my plan was just to throw a sphere in there and call that a gateway or a cube or some random shape and give it the name gateway. And then we go to the other scene when we get close enough to it. Have some expansions for that in mind for Wednesday. I suppose probably won't get to those today. But we want that to happen when it's close, not when the character is directly up against it. So a lot of times the mesh colliders are, I find I like those a lot better on the grounds and the surfaces, and then just boxes or cubes. That way we have that wiggle room around our character so we can make things happen when our character is near it, not directly smacking into it. But the mesh collider is there. It's a viable option. So now if we run this, it should hit the ground when gravity pulls it down. Yeah, so looks like he falls, hits the ground, stops moving. It's a good start. That camera's way out there, right? We need to do something about that camera. Because right now it's just like our object is sitting over there in the distance. The camera's sitting here, we can't change. We haven't worked in any controls to change it. And those can be a little complicated to code up. Because just like movement in our characters, matching that to animation and stuff, every one of them ends up being somewhat unique and taking some little refinements. But Unity, they're a big, huge corporation. They kind of got their choice of best programmers. So some really, really good programmers were able to generalize a lot of that stuff. And we saw it the other day. If we go to the window and the package manager, and wait for this to pull up. So here's the ones that are already in our project. I don't have Visual Studio on here. I don't know why that's looking at that. Version control things, a couple pre-built things already in there. Or Unity registry, which on my other machine, that label always says all packages. I don't know why it seems different on different machines. But I've seen at least 3 or 4 different names for it. So it's inconsistent, but there's clearly a label that refers to every package. Whatever yours has it labeled for every package. If you look there, you'll see Cinemachine. They're in alphabetical order, so you can scroll down and find it, or just start typing it in the search bar. But we saw this in 2D the other day. A whole lot of the standard camera things are pre-built for us. So we can just use those instead of writing those scripts all ourselves. So just find it in the package manager and hit install. Or sometimes the labels are different, even on the same versions of Unity and stuff. I'm not sure why the labeling seems different, but sometimes buttons say install, sometimes they say download, import. We'll see different labels, but they clearly mean the same thing. And let's give this a minute to do its thing. And this makes the camera work a whole lot easier because we can use these pre-built things that just need a little bit of configuration to get what we want out of them. And I think that, yeah, the Zoom call kind of slows everything down, but shouldn't take too long. There it goes. But you can kind of see things flash in the background because Unity restarted. But once it's installed, the button will say remove. Or if you go back to the packages in project, you'll see Cinemachines in there now. But whenever it's there, we can close out the package window. And our main camera's zoomed way out. The other day, we looked at a virtual camera with 2D, and a virtual camera is used to pass instructions to our main camera. There's different ones here, as you can see. A good one for 3D that fits some standard ways to set up a camera, I guess. Couldn't think of a good word for a moment, but some of the standard ways we use our camera, the normal two-handed PC gaming ways, is this free look camera. So if we bring in a free look camera, see it just kind of, it noticed this character there already. So it kind of applied it to that. Is that okay? The way it was set up, it looked like it was a child of that other one. Probably don't want it as a child of that object. We just need to do some configuration. And some of it may look familiar. You'll see a lot of words that look similar. I zoom out. Not really seeing much yet because we haven't told it what to look at. We want to follow our players, so we'll have those, oops, same options we saw on the virtual camera, follow and look at. And in this case, we probably want to follow and look at our camera, look at our player. And remember to use that player object that is the parent of the image. Unless you just went with the image, that's a good starting point too. But it can be very useful for you to put them together. Once it compiles, the compiler will notice that that would be more efficient if those were turned into one single object, and we'll do that for the version that actually runs, but it helps to keep our code organized. And well, the biggest thing is when we go to replace images, we don't have to replace the whole object, we just replace the image in that object, one little piece of it. So now you'll notice a few things about our camera here. It's sitting there by the character, and then we have these three rings. And white lines showing what it's looking at. So the white lines show the view area. And then these rings are the orbits. We're in 3 dimensions, so we can spin it all the way around or move it up and down. And those are called orbits, so we want to adjust those. So with the free look camera, the basics are set up your follow and look at parameters. And then if you scroll down just a little bit, you'll see orbits. And there's a top, middle, and bottom. And on the way down, I guess you'll notice there's axis controls. Scroll right past them. There's axis controls, which by default, the y-axis is input to the mouse Y, which you can change that, just like we saw from go to project settings, check the input manager, get the name of different input axes. But the mouse Y is a very typical one to use, or x-axis is controlled from the X. But we could have our mouse in different positions, and that's what the orbits are. So if we're down at the bottom of the screen, we're in this little circle down here. If our mouse is around the middle of the screen, we're orbiting around this circle, and up at the top of the screen, we're orbiting up here at the top rig, I guess is the name here. So we want to set some things for those. So I'll set the bottom one, maybe like 0.3. So it's near the ground. And then how big is it? So maybe like 5. So you see it forms this circle around the character. We are looking at a strange angle there, so you can see the character is centered in that circle. Then as we get a little higher, maybe 4 off the ground, spread that radius out, like 10. So a much bigger circle. And when we get up a little higher, maybe around 7, right, 21, something like that. A nice big orbit. So this is a control that should look somewhat familiar. So it depends on where our mouse is vertically, which one of those orbits we're following, and then we just kind of move our mouse left and right to spin around that circle. And just personally, I've found that it seems to work better if I start the game looking from roughly the same angle. Sometimes the mouse will be in a different spot, or it'll be looking at start at a strange angle and it's harder to get back to the right spot. So with this one, I found it's best to have the scene view roughly in the same angle. And after hitting run, while you're waiting on it to start, go hit the play, kind of put your mouse in a good starting position, roughly the center of the scene, basically. You see our characters there. And as we move the mouse up and down, we're zooming in and out, which is probably a little jumpy on the zoom call. But up and down moves it in and out, and moving left and right circles around our character. So some controls that you're probably somewhat familiar with. And those are going to be your basic starting points. You'll see there's a whole lot of things here. So, well, part of the plan for today is to leave lots of lab time to go in there and play around with that, make a change, see what happens. But you'll want to at least have those values. And I need to figure out how to turn those hints off without getting into the source code. I know where it's at in the source code. I can go take them away from the UI, but they kind of get in the way sometimes. You want to at least set your follow and your look at. And I guess what I just said about playing around with this in lab time, those hints are going to be very useful. When you hover over stuff, you'll get a little description pop up saying what that's going to do. But you just want to make changes. So set up at least the follow and the follow and look at, and then scroll down a little to your orbits and set the height of it and the radius it's going to be, and find some good controls there. And as you scroll down, you'll see some other things. We saw like the dampening, slow down how quickly it follows, because usually we don't want our camera moving around as quickly as our character. That would just make the whole scene look jumpy. We're going to slow the camera down from the character. The dead zone, which is the area the character can move before the camera starts following it. But y'all can play around with those, give things a try. That does make the camera follow a whole lot easier. And that Cinemachine is built into Unity, ready to use. So that gets our character on there, and the camera following him. Now we're ready to make him move, right? And then animate him, which looks like 2 o'clock. So it might be a good time to take a break. I was thinking 2:15, but if we wait 15 minutes, we'll be in the middle of something, right? So I guess we can go ahead and take a break now. Does 10 minutes sound good? And then we'll get back to this, and that way we won't be in the middle of something at 2:15, which would the normal time that I'm usually looking for when I think break. But
yeah, that sounds good.
All right, yeah, that way we're between subjects. We're not in the middle of something. So we'll get back to this at, well, the clock's probably about to flip over. So we'll get back to this at 2:10, and I'm gonna go grab a cup of coffee, and I will see y'all in just a moment.